Sweet. So as you can see, I'm standing up here in beautiful San Francisco, right behind me, thanks to my IKEA desk and some somewhat good machine learning detection. Cool. So I want to talk to you today about architecture and how to keep it simple, and tell you a little bit about our story over at Ollie. I wanted to go over how we tried to simplify our architecture, where we started, where we ended up, and talk to you about the map of the different options, and then talk about the 9 different architectural styles as I've defined them here. And it was good to hear that a lot of us were using some of those styles, some of us going back and trying to simplify as well. So that was also interesting to hear. So before I get started, I want to talk a little bit about myself, and so you can kind of understand where my background is and where I came up with some of these ideas. And obviously my background affects the view that I have on architectures, because your experience is reflected in how you approach problems. And it's just my experience. So take it with a grain of salt, but please be open to these ideas. And I would love to hear your ideas after the talk as well. So like I mentioned, I'm a software engineer at Ollie Order, and I'll talk about Ollie Order in a second as well. I started doing software or web development, not really programming, opening an HTML page in Notepad and editing it, saving it to the desktop, opening that, and you had a web page. The glorious Web 1.0 days. Oh, how we miss you. Professionally, I started working in a university in 2010, worked for some bigger companies like BlackBerry, did my internship there, and then I worked with some mid-sized companies, and I was kind of tired of all of that stuff. And whoever can push up on mute, it's Robert, maybe. Thank you. So I was kind of tired of the corporate stuff. I wasn't there for very long, couple of months, and I fell in love with the startup community. Kind of jumped between different roles in there, started my own startup at one point, did consulting, did some UX design, even did some project management. And then I landed back onto what I love the most, which is coding. So I kept doing coding, and I found I really enjoy building product. So I joined a product company called Ollie Order right in the beginning when we were starting building a new version of the product. I'll talk about it. And when I'm not coding, you can find me usually snowboarding, you can find me cycling, and obviously Ollie is an alcohol company, so I have alcohol here by law. And my favorite beer is, we had this beer in Spain, a habanero lager. It's a spicy beer. I've never had it here since. It pairs really nicely with nachos and Netflix, actually. So really good stuff there. So Ollie's a startup in the B2B alcohol space. We're trying to modernize alcohol in the B2B space, where we also have some adjacent fields that we're also going to expand into, in beverages and things like that. We started with the first version building on Spree Commerce. I wasn't there yet in January. Then a few months later, we learned a lot about our market. We had, it wasn't really an MVP, but we had a kind of a proof of concept, I would call it. And we went to our customers and showed it to them, and it was a marketplace. They didn't really want the marketplace. They wanted a tool to make it easier for them to process their sales. We built a tool for the sellers. So the problem in the alcohol space is we have a lot of companies in the space, a lot of sellers that started in the last 15 years with all the microbreweries, distilleries, and so on. And they don't have a lot of systems in place yet. And the buyers also have to talk to a lot of different sellers in order to do their reordering. So it's just very inefficient for both sides of the market there. So for our second version, we decided to focus on the sellers. We wanted to give them the tools they need to process sales, do reporting, manage inventory, and just use their whole workflow and help their salespeople. So we started 3 developers in March. Our first task was to pick up a tech stack. We all knew Rails, we all knew React. So those were a couple of easy choices. Then we wanted to pick some stuff that we're really excited about. So everybody was talking about GraphQL. So why the hell not GraphQL? Let's put it in there. That really wasn't the entire reason why we chose GraphQL. The GraphQL reason was because of our previous experience with Redux. We didn't want to repeat our Redux pain points again. We actually all built Redux application. Didn't really like it, found it was really complicated, and we wanted to find a better way of building things. Apollo seemed like it's the new solution to not having to write as much boilerplate. There's a lot of articles at that time about that, so it seemed like a sensible choice. And that kind of forced us into not building RESTful API, but building a GraphQL API, which also seemed like it's going to be the future of APIs. We also decided to build our own design system. We tried a few of them. We tried Bootstrap, and we tried, what else was in there at that time? We tried Bootstrap and we tried, Material UI. That was the other one we looked at. It was a bit too rigid for the design that our designer wanted, which was also one of our developers. And he said he'll just build the design system for us and integrate a bunch of components. Sounded good to us. 3 months later, we had our MVP. Things were going pretty well. We had 2 contractors join us and with expertise in payments and a bunch of business logistics stuff that we needed help with. And then in October, we bought another company called Sales Leader, which is a company that's been around for about 10 years. It became part of Ollie. So we now had 2 products, one that was in Rails and React and GraphQL and so on, and another one that was PHP and Angular and RESTful. And that product was built by a single developer, and it took a much simpler approach to our stack. And it made us think about what we could do if we kept it simple. So on the 1-year anniversary to starting building from scratch, we decided to sit down and think about what if we made it simpler. Obviously, COVID-19 kind of happened and interfered with our plans. So we had to build a bunch of features and delay it a little bit further. But once we sat down again, the first question is, where do we start? We started with defining the problems. We sent out a developer survey to all of our developers. We marked all the pain points. So there's a bunch of them. People didn't like GraphQL. We had a bunch of boilerplate. Took a lot of time to build things, and so on and so on and so on. And then the next question is, we wanted to put our options in one place. And the question is, how do you organize our options? So we kind of listed our options. And at that time, like the real answer to the question, what do we do and how do you organize it, is what do you do when you get lost? When you get lost, you look at a map. But if there is such a map, I have never seen one. And everywhere I searched, I could never find one. So I had to invent one. And one day I was thinking about how to put these options together. And it kind of came back to me my university days at business school. And later on, I took startup school later on. And I remembered that business people are really good at putting things on graphs and diagrams. And they have some things called positioning graphs, which you position your product on 2 axes that you choose. And then I remembered the best graph that I've ever seen, which is this one. So I wanted to be part of the conjoined triangle of success of Jeff Barker. We wanted all the growth, we wanted all the sales. So that was the graph that we used. Obviously, that wasn't the graph, but really I chose 2 dimensions that seemed reasonable. So the first one is the complexity of our design. So how complicated is our architecture? The second dimension is the complexity of our requirements. And in the ideal world, your system design complexity and your requirements are one-to-one. So your design is just as complicated or just as simple as it can be to support the requirements that you have. And if you think about it, if it's a one-to-one mapping, then we can draw a line right in the middle, and that's going to represent the ideal line of architectures that we can have. And then all we need to do at that point is just to chart out the different options that we have on this line, and each one of them is going to represent the ideal architecture for that specific level of complexity, because that's why they're invented in the first place. And that's what we're going to talk about today. So we're going to talk about these 9 different architectures. Don't worry about all of them right now. I'm going to talk about each and every one of them in glorious, beautiful detail, and we'll focus on a few of them more than others. And also, I'll have a bunch of information on these slides. You'll get these slides after, and I'll have a beautiful long article for you to read and enjoy. So don't worry too much about if you missed a slide, it's okay. Cool. So the first architectural style is kind of no architectural style at all, if you will. It's the no-code, low-code architectural style. I chose different images here to represent the first image that came to my mind when I was thinking about this architectural style. And the first image that came to my mind was a city up in the clouds that developers are too afraid to climb up to because it can fall down and not code or something. But it's usually an architectural style we don't really think about, because for developers, we like coding. So we like building things, new things, but we don't always have to build things. Most of the times there's tools that are already built for us, and we can use those tools and configure them in a way that suits our needs. So that's what this style is about. I divided it into different categories. So there's a few categories here that we can quickly talk about. So the categories are general purpose tools, and I divided them between hosted and not hosted tools. Airtable is one tool in that pile, Bubbles, Glide, and so on. It allows you to build entire apps, just general purpose. You can do anything you want there pretty much. You can build a whole web app or mobile app. And you can do a bunch of stuff with WordPress on your own, host it. And then you have things like site builders in there. You can build a simple website with drag and drop. We have specialized tools like the Twilio Studio Admin and Algolia. That Algolia does search, Twilio Studio does telephony services, and you can build a whole call center and all the logic in the call center for yourself. Then we have a bunch of things like CRMs that you can have. There's analytics, there's ERP platforms. And then most of these tools need a way to integrate and talk to each other. So there's tools that integrate to these tools. So we have Zapier, we have If This Then That, Segment, Automate, .io. And I even found a bunch of tools to do web scraping if you ever need to get the latest data about snow conditions on the mountain and put it on your website for some reason. You can do that. And you don't need to write any code. So the advantages here is that you can get started really quickly. It's really inexpensive for you to build stuff. You can experiment with things really quickly. It always improves for you. So the developers of these tools, they keep pushing updates and the tool keeps improving on you. And they generally use the best practices. So you get a lot of things like SEO for free if you're using WordPress or one of those website builders, and you don't need to worry about these things. The problems with these things are that it's never really a perfect fit for a use case. You still have to learn a bunch of things. You have data in different places. You get locked to the vendor usually. There's no staging and sandbox environment in a lot of these tools. And there's no way to check your, there's no way to check that things are still working for you, which is a big problem if you're making money through these tools. If you're making like $10,000 a month or more on these tools, and it pays for your living, you probably want to make sure that it keeps working and generating revenue for you. So you want to test it. The next thing are static websites. So kind of like what they sound like. It can be really, really simple. It doesn't have to have any build process or anything like that. It can be as simple as Web 1.0, where you have a bunch of HTML in a page, you edit with Notepad or whatever tool you want, whatever editor, save it and drop it onto some box or S3 bucket or whatever you do with it. There are a bunch of tools that build all this stuff for you to save you from duplicating code. So we have Jekyll, we have a bunch of stuff. And then we have the newer stuff. The cool kids use Jamstack. Jamstack stands for JavaScript APIs and Markup. Gatsby and Netlify are kind of the glorious child there of that type of architecture. They let you upload things really quickly. So you use APIs for any dynamic content stuff. You can do login, you can do shopping cart, you can do CMS with all these APIs, and you just store everything on your source control system, those markup files. It's pretty easy to use. So again, it's simple, it uses web standards mostly. It's fast. It's fast from the user's perspective because it's lightweight. It's also easy to build and fast to build. It gives you a lot of flexibility, and it's just really cheap to host. The drawbacks here are that you don't really have a lot of dynamic data that you have access to directly. You don't have any database there, so you have to rely on third-party applications or third-party databases with all their data silos and trying to figure all of that out. And you'll see how similar this is to some microservices architecture much later on. Some of the other ones is that you have some security challenges. It requires a bunch of third-party integrations that you have to write yourself a lot of the time. And SEO is not, as I learned myself, because my website is using Gatsby, I switched from WordPress. SEO wasn't one of the things that I paid too much attention to, I forgot about, until 60% of my traffic dropped, which I didn't really care about that much because it was my personal website, but still it wasn't the greatest thing to see. The next, we're starting to get into the more interesting and sophisticated ones, and more of the stuff that you'll probably be working with. We're almost there, probably not quite. There's a whole movement of what's called Frameworkless. The idea is that you reduce the amount of dependencies that you have. You only really require the libraries that you must. So you don't have a big overarching framework that's going to dictate your architecture. And I think about it as just a big empty field, and you can build whatever you want on that field, but you just don't have a lot of infrastructure to build it with. So you don't have switch systems and things like that, probably, but that might be okay for you. So in here, you usually use pretty much language features. Some of the tools that you might want to use there, you can use like a raw node server. You might use some lightweight services like Express, Sinatra, Flask, if you're on Python side. And you can take both these approaches on the client and the server. So on the client side, you can choose not to use a big SPA library like React or Angular or Vue or so on. You can just use the DOM API and maybe underscore, or not even that if you don't want to. So some of the advantages here is that it's really simple. There's no learning curve except the custom code that you actually write. So it's minimal, it's fast. There's a lot less things that can go wrong. You don't have this giant package.json that eats the entire universe for you. But the cost for you is that you need to do all the integration yourself. you need to write a lot of custom code, and you probably don't have a lot of community support, especially if you're using something like JavaScript and you're trying to ask around the community, how do you do something? And people usually point you to whatever framework at the time that's most popular, and that's how you do things in those communities usually. Next, we have the MVC architecture. I used to call it the traditional MVC architecture, but I since removed that word traditional because the word traditional and modern implies that modern is the way we do things now. Traditional means the way we used to do things, and that's just not true. These are all still valid choices that you can make, and you have a lot of choices. And I hope that that's what you see here, is that you have more choices than you probably thought. So MVC architecture, MVC was one of the first patterns out there. I have a city of Rome in here, and everything is pretty structured. You can see the different structures in here, and the schematics of it look a little bit like this. So you have a really thin client. Most of the times that's what's in the browser. It sends a page request, and it goes through the controller, it calls the view interacts with a few models, the models can interact between themselves, the view sends a rendered HTML back to the controller sends it to the server, which is going to be the router in this case, and then it sends it back to the client as HTML. So it's really simple request response model in here, really easy to see where things go. It separates the business logic and the presentation logic really nicely for you. So models have all your business logic, the view has your presentation logic, and the controller kind of orchestrates between the two of them. So there's a lot of different frameworks here that you can use. There's Rails, the Django, Sails, Play, ASP.NET, Phoenix, Laravel, and I tried a bunch of them throughout just preparing for this talk, and they're all pretty similar and they're pretty great. So if you use one of them, you can probably use all the rest of them. Data requires you to usually do page reload, so fetching new data requires a new page to be loaded, and sending data, you just do it via HTML forms. And one more thing you might have missed is that this is actually a reactive architecture. So if you actually think about it, every time you make a request, you get a response. So, and you change the state based on your request. It's not as granular as something like React that only changes part of the page. It changes the entire page. But you can also think about it that way, and it'll help you build things. And that was one of the advantages of early versions of React, that they kept this really simple request response model. In their case, it was the state change model, and you get a new state. So again, simple advantages, simple model, really mature. You can build things really, really fast. Your initial load time is usually really low because you don't need to load this giant JavaScript file that's 25 megabytes of framework before you can do anything. It's really easy for SEO because the web crawlers don't need to load all your JavaScript and execute it. So they can just find things on the page really easily. You have a lot of caching options in these. And you generally have pretty well integrated components. And the asterisk there is because as soon as you want to do something a little bit more complicated with these components, you usually don't get the best integration there, and you'll need to write some custom JavaScript code to do that. The disadvantages that it's not possible to build some UI without JavaScript. You just need to do some client-side logic, and you need to change things like state on the client side to get your components to behave the way you want. Some of the UX around this is really awkward when you have to redirect the user and you see a flash of unstyled content. That's really awkward. There are ways to get around it with some libraries like PJAX and TurboLinks that do the loading for you and avoid some of these problems. They're generally larger requests. So you don't just pull the data, you pull the data and the presentation for the data. So obviously it's going to be a little bit larger. And your network latency is a big factor in that. You can't really do things without loading the next page. So if you lose a network connection, you're on a slow or fragile connection, like on a mobile device, it's probably not going to behave exactly very gracefully. So this is where the new kid on the block comes in. There used to be just an empty space in here between MVC Web Architectures and client-side, server-side, SPA kind of architecture. There used to be nothing here. Now there's a bunch of different libraries, and it all started with one library, one beautiful library called Phoenix Live View and the Elixir language. And Phoenix Live View did a really simple thing. It said, why can't we do a reactive loop on the server? So we open a WebSocket connection that's persistent. You send us a request to update the server state. We render the HTML on the server side, and then we send you only the new HTML that has changed. Then we apply those changes on the front end, and it's essentially giving you a reactive loop on the back end. So exactly like React, it just happens on the back end. So that was a really interesting idea. And there's a bunch of different frameworks that came out of that. One of them we're using, it's called Stimulus Reflex. It's not as smart as Phoenix Live View in the sense that it sends you the entire HTML to the client, and then the client itself compares the HTML and does a different, but it pretty much works the same way. So here we have the clients that you can still send server requests, but as soon as you do, you can also go through these things called reflexes. That's how you update your server. Instead of the controller, it renders the controller action for you. Controller action renders the view. It gets data back, and then it sends that data via WebSocket back to the client, which does the diffing. Or if it's Phoenix, it'll actually just send the diff. There's a bunch of other frameworks out there as well that do this. Another interesting thing, because it's a WebSocket connection and you have WebSockets across all your clients, is you can easily broadcast updates to all your clients at once. So if the status of an order updated and you have two users viewing the same order, for example, we can broadcast an update to both users, and then they never look at stale information. That's really interesting and really easy to do in this kind of scenario. And it's harder to do in some of the other architectures. So it builds upon MVC pretty much as you saw in this diagram. It adds this, kind of talked about most of these things. And there's a bunch of libraries in here. There's Stimulus Reflex on the Rails side. There's Phoenix Live View, Blazor server, which I really admire on the C# side. Really beautiful. You should give that a try. Socket Puppet on the Python side, and Livewire for Laravel and PHP. So you should be able to try this. There's probably a library out there for whatever language that you're using. The advantages here is that you don't need to write your own dedicated API layer anymore. So you can save a lot of time there. All the logic stays on the server side. You don't need to duplicate your logic across the server and the client side. So like your form validations and things like that can all stay on the server side, and you can just get at the data that you need without having to write extra files and defining extra things. It's a pretty simple mental model that you're relying on. The biggest disadvantage is it's pretty new so far. There is some problems we just haven't solved yet, and you'll start hitting them pretty early as soon as you get there, but it does work. And another big problem that can never be solved is the network latency. If your users are really far away from you, you'll always have to suffer through this network latency before you can actually make UI updates. But if most of your users are on a pretty good connection, it doesn't really matter. The other weird thing is that the UI state is kept on the server, and it can feel kind of awkward and the wrong place to keep it, but it does work just fine, and it opens some new possibilities for you. And on the Rails side, we just don't have a good isolation of state yet between components. A component view system is not well implemented yet in the Rails community. It's not true for Blazor, and it's not true for Laravel. Those are first-class citizens in those communities, which is really cool. Finally, we get to probably the kind of architecture that a lot of you pick as a default, as we did. It just seemed like the right architecture that everybody picks. But as you can see, it's pretty high up there, and we have a lot of other choices that we probably never considered. But it's still a really great architecture. So here I have the San Francisco Bridge, which is also right behind me here. So I'm still living in this architecture somewhat, as you can see. But the idea behind this picture is you have two banks, so the client side and the server side. They're connected via an HTTP connection or a WebSocket connection, and you transport data between the two of them. And there's a big gap between the two, and you probably saw it in your work. There's a big difference between a front-end developer and a back-end developer, and the gap is kind of widening over the years. And those are some of the problems with these architectures. But it doesn't have to be like that. The concept is really simple. In fact, so your client makes a WebSocket request or AJAX request, doesn't really matter to the server. It does all the same controller stuff usually. Instead of an HTML view, usually talking to a serializer that serializes data to JSON, whatever gRPC or binary formats that you want, and it sends it back to your client. And I have a reactive loop there on the client side, right next to the user there, just because that's what most of the front-end frameworks these days do. They have a nice little way to update the UI without having to go back to the data without having to go to the server for data. So really interesting stuff there. Generally, the client is in charge of UI rendering, server is in charge of your data fetching, the business rules, and you can build all sorts of different communication protocols. You can use REST, you can use GraphQL, you can use RPC, you can use SOAP if you're still doing older legacy systems. Probably don't do it otherwise. And you can just use whatever communication medium you want, HTTP or WebSockets. It's really nice that it couples your UI and data. You can deploy them separately, you can work on them separately, you can have two different people work on things. You have a lot of flexibility on your client, and you pretty much can do whatever you want there. And that's why front-end developers really love this style of architecture. It gives them a lot of freedom and choice and desktop style quality if they want to get there. And it's pretty simple to understand conceptually. You're just shuffling JSON data back and forth. There's not a lot of complexity in that regard there. But it does require you to build a dedicated API, which takes time. You can have a bunch of errors there, miscommunications and things like that. You have to constantly sync data back and forth between the client and the server, and you have a lot of duplication of data. And by what I mean by potential mismatch is that, for example, your client-side validation and your server-side validation, the logic can get out of sync there because you can have two different people working on it, or you just have the code in two different places. That doesn't have to be true. If you're using something like C# and Blazor WebAssembly, you can write everything in C#, and you can share the validation logic between the client and server in one code file, which is really great. You can do the same thing with something like Node and Meteor, which is great, but not a lot in between there. So that's pretty cool. And maybe one of the advantages there is that you could write it in two separate languages. Maybe it's good for your team based on what type of knowledge you have on your team. So finally, you have these really interesting architectures that I've heard people moving to and moving from, and they're really interesting to me. And I thought that I didn't have a lot of experience with them, but I'll show you what I learned here. So I chose this really nice picture of a forest. That's how I think of microservices. I think of them as a lot of different organisms that are absolutely independent. But if you know about forests and how trees actually communicate underneath the forest, there's an entire network of communication between the trees, and they share resources and things like that between each other. That's how I think of a microservices architecture. And if you look at this diagram, you'll see exactly what I mean. So in here, we have a client, and we have this beautiful thing called an API gateway. The API gateway just delegates control to the right microservice. Each microservice does a different thing. And generally, you want to try to avoid, well, you'll have to have them communicating at some level, but the more independent they are, the better it is. Again, it goes to just normal, good system design principle of decoupling your concerns. So here, each one of them has a different data source, and they can communicate between each other via any protocol that you want. They can do HTTP, they can do gRPC, they can do socket communication. And I don't mean WebSockets, I actually mean sockets. And they can use event buses like RabbitMQ or anything like that, and just pull off that event bus for you. So here I have them isolated to different things like user management, order management, inventory management, and delivery tracking, to give you a good example of what it might look like. And the order management has to talk to the inventory to get the inventory data update, the inventory status, and it also sends stuff to the delivery tracking system. So that's pretty interesting. Generally, they're designed to, from the pain points that it come from is we had a giant server-side monolith. We wanted to break them down so that separate teams can start working on the different pieces, and each one of them can be deployed separately. The idea for microservice is not new. It originated from service-oriented architectures that people talked about in the 2000s, and way earlier before that, it originated from some much older systems that I wasn't around to see. But the difference between a service-oriented architecture and a microservices architecture is that in microservices, every service is isolated into a separate process, and they need to use inter-process communication to communicate between each other. So they live in different worlds. Whereas the service-oriented architecture, you can actually have them as modules in the same system. So that's really interesting. And if you actually look at it here, and if you've done serverless, you'll see we still have this API gateway. And if you think of every little service as its own function with its own data source, you can also say that serverless is a sort of microservice architecture. But you can go even further, and you can start, if you really start thinking about your system, and if you have something like a payment system like Stripe, Stripe has its own data source and you use it as a payment service. So are you actually in a microservices architecture, but you never realize that you are in a microservices architecture? So that was one of my realization about our system, was that we are actually sort of in a microservices architecture, and we have the same problems, and we can actually use some solutions that people in a microservices architecture use in there. So that was really interesting, because I didn't think that I would ever need to know about this architecture. So that was really interesting to me to learn about it. And if you remember, I mentioned that we bought 2 tools. So we bought another tool called Sales Leader, and we integrated into this tool. So essentially, Sales Leader is a separate service that does inventory management for us and a bunch of other functions, but that's how we use it. And we talk back and forth between there, and we have the same UI that talks to the inventory management, that pulls stuff from the inventory management system. So again, we have all the same problems of microservices architectures. So let's talk about the pros and cons here of microservice architectures. So the main value of them is that different teams can work on each microservices. They can deploy them on their own time without affecting the rest of the system. They're really simple code bases. You can test the whole code base in a couple of minutes usually. You can use many different languages, and it can be a great benefit to you if you're doing a lot of integrations. And it's easier to define boundaries for the teams to stay within and communication between the teams. So the biggest disadvantages is that it's really hard to test the entire system. You don't necessarily have control of how data is represented in the other microservice. You have to have a really good strategy to integrate all of them, to wipe the data, to restart data. And it multiplies. The more languages you have, the harder it's going to get for you there. It's also really important to get your boundaries right in the beginning. You can keep breaking down things into smaller microservices from a bigger microservice, but to change the boundaries of a single microservice to encapsulate the responsibilities of another microservice is going to be pretty hard for you, because you're going to be breaking a bunch of APIs along the way. It's also going to be hard to trace errors across the system. If something breaks in some microservice 20 layers deep, it'll be really hard. And probably a lot of you are thinking about the map of microservice architecture, the nightmare map of Uber for microservices, but I'll remind you that Uber is billions and billions of users and in multiple regions, so maybe it makes sense for their size. One interesting thing that actually latency compounds across the number of services that you have to call within each call. So if your user wants to see write data and you have to call 10 different services to accomplish that task, well, guess what? You're going to pay for those 10 different network requests between those services. So you want to use something pretty efficient, maybe like gRPC that opens a socket connection and exchanges data in binary format. It'll also increase your DevOps complexity a lot. So you should have some good DevOps people on board. So our penultimate architecture here is the Frontends architecture. It's a newer style of architecture, and it's designed to address some of the problems with the microservices architecture. And you can see how everything kind of increases in complexity. That's on purpose. So I think about the Frontends architecture. The front end of a tree is the leaves. That's what receives the light and does all the interesting stuff anyway. So yeah, so you have the leaves here. It's not that complicated. It looks something like this. So you have a container application, and your goal here is to break down a large UI monolith so that multiple teams can work on the UI. And you want to make it so they can work in a cross-functional full stack team, so they can address the entire stack. So here I have an app container. Each micro front end is in charge of its own little world. So the user management is in charge of all the user services and the user data. And then the order system is in charge of the order management service and the data there and the inventory and so on. And again, you don't want them to, as much as possible, you want to avoid these connections here that I have across the micro front ends here. If they do need to communicate, it's much better to go up into the container and try to communicate that way. It might not always be possible. You might need to do updates between your order management and inventory management that doesn't necessarily update the UI right away on that screen. So that's really interesting. Yeah, break it down. Another important concept there is that you want to pull down these micro front ends here at runtime because you want them to be independently deployable. So each one of them will come from a different URL usually, and it'll just be on your production. So it'll come from like users.example.com, order management.example.com, and so on. They can use different UI frameworks if you want. So you can have Angular, you might be switching to React, Or you might have React and you switch into Vue, or whatever the new framework of the day is. So you can let the team choose whatever framework suits their needs. So again, independent deployability, you get to choose whatever libraries you want. You get autonomous teams on there, and you get simpler code bases that are focused on one little task. Having all these different libraries that you can use against every little micro front end also increases your bundle size. So that's one of the biggest disadvantages there. There's some inconsistency between UI teams, but you can always have a core or design system team that kind of takes care of some of that stuff. There's some DevOps complexity, and you'll get some problems with the environment being different between production and development. Each one of those micro front ends, you can think about them as an iframe, and you can implement them that way as well. So each one of them lives in its own like iframe. It's a full page. You can think about it like that. And then each team just looks at their own little page. But in production, they're all one page. So there's a bunch of other things, that dependency that they don't see necessarily at development time. And that will increase your bug rate and things like that. Obviously, you don't have to use iframes in here. You can actually use something like React and mount components and unmount components. And Martin Fowler has a really good article on his blog about this. So you should read that if you're interested. So finally, we have our exotic architecture. And the reason I put them there, and some of you might not think they're that exotic or you have a use case specifically for these things, is that I've just never seen a use case for them. Or it's not that I've never seen a practical use case in the applications that I worked at, but I can think of many use cases for them, just not in my work. So I usually go there to play around with things and relax. That's why it's exotic to me. So here we have things like CQRS. So CQRS talks about using events instead of modeling your current data as a single object. And so for example, we have an order. Instead of having an order, we'll have an event. Order was created, order was updated, order was published, and whatever states the order is. In order to see what the current state of an order, we can just replay those events and see what the state of the order is. So these are great for knowing what happened at any stage in the lifecycle of the object. It's really, really nice to be able to play back into what did it look like 3 months ago, and you can see what things look like. Again, it's pretty young. The tools are not as well built to develop or understood by most of us developers. So that's what makes them a little bit more difficult to use. Then we have things like graph databases, and it was much bigger back when the social network movie came out, because everybody was talking about social networks, and that's a perfect tool to represent a social network, a graph, and you can look at the connections in the graph, and you can find your adjacent endpoints in the graph. It's also good for things like mapping. If you want to find the shortest route somewhere, you can use a graph and compute the values on that graph. But beyond that, I haven't found any good use cases. Some people think that it's easier to think in graphs than in relational data, but a lot of us are trained to do relational databases already, so it works well. The last one is blockchain, and one of the guys mentioned that he uses blockchain. So I'll talk very briefly about it and what I know and what I understand about blockchain. Again, it has a bit more limited use case or number of use cases for blockchain, but blockchain tries to create a distributed ledger across many different nodes that might be not trustworthy. And they also try to give you a compensation model for compensating them on work that they're going to perform to validate and authenticate whatever you're trying to do in the blockchain. So one thing there, you have things like smart contracts. So smart contract is a contract. It's a unit of work that you want to execute as the creator of the contract, and you give it to the blockchain network. Somebody in the blockchain network picks it up, they perform the work, and then they have other nodes that validates the work, and they all get compensated, usually in some kind of cryptocurrency. So that's really interesting there. Really great for things like finance, maybe voting and things like that. But day-to-day business, we haven't found the use case yet for them. So back to Ollie, and by the way, we're almost done. It's almost beer o'clock, so don't worry, just bear with me for just a little bit longer, and I promise I'll get you to the promised land. So looking at this graph, I kind of charted where we were in June 2020 when we thought about this architecture and made a decision as a team to move somewhere else. So as you can see on this graph, we were building a single page application. It was React, GraphQL, Rails on the back end, and Elasticsearch and things like that. And we had another product in there. So we're kind of moving towards the microservices architecture. Maybe arguably we're already there in a sense, but our requirements we knew they were a little bit more complicated than the traditional MVC architecture. We wanted to have a bit more interactive components in there, but not by much, and we didn't know how much. So we all sat down together. We decided to go more towards the traditional MVC architecture and build upon it for more dynamic things. We used Stimulus Reflex, which is the reactive architecture that I mentioned before. But we tried to really keep it simple and build as much MVC stuff as possible in there and move really fast. We also tried to get rid of our Elasticsearch and use a database search. Unfortunately, we couldn't quite get rid of having to use a design system, our own design system, just because the libraries around Stimulus Reflex are not mature enough to have their own well-integrated components yet. So we kind of had to build our own. We had to compromise there a little bit. And things like Bootstrap just didn't have the kind of components that we really needed. So there's not a lot of value in using Bootstrap. So we decided to use just Tailwind in there instead. And then we all went for a beer, and it was happy ever after. Right? Well, sort of. So now it's time for a conclusion. So the biggest thing I've probably learned out of this is that there's room and place for every single architecture, but it'll probably come as a shock to you, but there is no silver bullet. Same as the author of the Mythical Man Month, there's just no silver bullet. There was none in the 50s, and none in the 60s, and none in the 70s, 80s, 90s, 2000s, and there will never be one. So we don't need to look for one, but we should have discipline and look at our requirements. And the more time you spend defining and understanding your problem, the better you'll be able to define options and understand those options. And always list the pros and the cons. That's why I was trying to show you here. Hopefully you got that. There's pros and cons to each approach, and it might be appropriate in certain scenarios, and it might be right for your team and might not be right for some other teams. Always, so I have a hard time with this sometimes. I'm sure we all do. We get excited about the shiny new object in the sky. We get distracted and we jump on these objects. And these are usually not the simplest objects that draw your attention. You really want to start simple and boring. And if you have time, you can get more complicated and advanced. So focus on the problem, not the solutions. Don't fall in love with the solutions. And you'll see all the authors of all the libraries, they'll tell you that their solutions solves world hunger. It connects googly bits and integrates to the world. It's just not true. It has problems. It always will have problems. And if they can't answer when you would use it and when you would not use it, you should probably talk to somebody else. And I just wish we had Amazon review system for our technology stack where you can just see best reviews and the worst reviews, and kind of the truth is somewhere in the middle, as always. Also, I hope you know now that it's okay for you to go up and down this architectural map based on the understanding that you have of the requirements, or based on the actual evolution of the requirements over time. So we're also probably going to go up this complexity graph as we add more people and more teams, and as we understand our space more and more, and we add more jurisdictions and things like that. The final thing I wanted to point out is that your architecture really follows the organization structure. So you cannot change one without changing the other. And what I mean by that is the way you do your project management affects the way your architecture will work and get applied. So when you're doing a single page architecture with client and server, you need to break down tasks in that manner, and you need to think about how you're going to give it to what team and to what people there. So it'll kind of matter in how you design your teams around that. So if you have a microservices architecture, you want to design autonomous teams that are kind of cross-functional. And if you're going back, you want to kind of simplify things and get teams that can do full stack, maybe. So change both, really think about your process at the same time. Architecture is about organizing people to build code. So don't forget that. And that's it. So we can raise a glass now. I have this beer, and hopefully it didn't get too warm. So I'll drink that. And I'll tell you that we're hiring at Ollie. So if you enjoyed this presentation, you love talking about architecture, come talk to us. We love Ruby and beer and architecture. So yeah, so if you have any questions, I would love to hear them now as well. Go ahead.
Well, thanks, Mike. So this is like one of the moments at work where we want to clap. So I'd like to invite everyone to unmute and just give a shout out to Mike. You cannot do it spontaneously here. So yeah, please unmute yourself and just for a moment, shout out to Mike, and thanks for the presentation.
Thanks, Mike. That was awesome.
Thanks, guys. I appreciate this opportunity to talk to you. Hopefully you learned something.
Otherwise, yeah, the floor is open for questions, and just unmute yourself and throw any questions to Mike.
I do have a question about the Reactive server architecture. I've seen the video by the guy from Silicon Valley, as someone said before. It is very amusing. But and I've heard of these kind of architecture since last year. I think it was a Phoenix. Phoenix is a it Elixir?
Yeah, correct.
Yeah, so I had a friend on the conference, and everybody was awed by this. But I guess for backend people, and the backend in me says, okay, I don't have to write JavaScript anymore. I don't have to fight browsers anymore, or something like that. But the front end in me says, well, things are usually not as easy as that. You get to a certain point where you have a functionality, a requirement that has some complexity that requires you to have some freedom on the front end. My question is, how mature or how flexible, or what are the limits from this architecture today and the technologies available in your experience?
Yeah, that's a great question. So it doesn't eliminate completely the need to write client-side code, nor should it, actually. You have a lot of HTML and CSS have a lot of capabilities built in that some of the frameworks kind of obscure, and they improved a lot. So one of the first surprises there was, oh my God, we can do things without always going to React. So that was really interesting and nice. In there, we also have, so Stimulus is actually it's a really modest client-side framework that Stimulus Reflex is built upon, and it does all the reflexes. But it's kind of, you can think of it as an alternative to jQuery, if you will. So we actually write Stimulus code that modifies state on the client side. And then when we need to do something bigger or to involve data changes, we just go to the server. So we can do that, absolutely. And we had the same concerns there as well. So one thing you can do is to change your requirements to keep things simple, right? So you can say, hey, we're trying to build this thing really quickly. Can we kind of cut back on some of the interactivity? Do we really need it? For a business application, do we really need it? That was one of the big questions there. But at the same time, and they'll say that in the guides for all of them, it's designed to answer 80% of the problems, and then the other 20%, you can still use React. So that's what I was saying, that if we can't make it work, I'm not opposed to going back and building some React code at the same time. So that's not a problem.
Does it integrate, or do you need like a separate channel for the React stuff or any framework? Or can you integrate the state from the server reactivity into the current front-end technology?
Kind of, not exactly. If you ever build multi-page applications with React, this has all of the same problems. So React will not know about the state until you tell it about the state. So you can pass the state back down as props to React, and it will kind of reinitialize them. Like some of the issues that we're having right now with Stimulus Reflex is more around, we're dealing with them today, was around testing, automated testing. It just takes a second for it to establish a connection, and the test sometimes actually interact with it before it establish a WebSocket connection. So we need to account for that. What happens when you disconnect when you lose connection to the channel at that time? It needs to queue the events. It doesn't do that in the best way yet, but it's getting there, and it was surprising how many things you can actually accomplish with it. So our plan is to, if we really can't do it, can rewrite the page or a couple of pages in React, and that's fine as well.
Thank you.
Anybody else? Don't be shy.
I'd like to ask a question, actually.
Yeah, great job.
Hey, yeah, I'm a web developer on the marketing team, and one of our projects is actually migrating our middleman static site from basically middleman over to Gatsby. And I just wanted to get your, I guess, opinions and what your experience has been like working with Gatsby. Like pros and cons, things you liked, things you don't like?
Yeah, it's a really good question. I actually use both Middleman and Gatsby now. I really like Middleman. So Middleman, for those of you who don't know, it's a Ruby static site generator. It's really nice. It allows you to do a bunch of things like upload your assets to CloudFront and build everything together. It's really fast. So Gatsby, the thing I really like about it is when you actually load the website, it's really, really fast. It has things like offline mode built into it. Again, you might not need it, but it was kind of cool to build it on my website personally. SEO was one thing I forgot about with it, but Middleman, and there's not a big difference there between Middleman and Gatsby. There's a plugin for everything in Gatsby. You just need to find the right plugins. It comes really bare bone, but there's a plugin for dark mode if you want to, like the switch for dark mode. There's a plugin for anchors for GitHub style anchor links for your Markdown files, a plugin for Markdown files, and then you just end up writing React code. The weird part about it is, so it relies on, for data fetching, it has a GraphQL API for data fetching. So you talk to this GraphQL API to fetch like your posts, for example. If you're writing a blog, you'll fetch your post, the title for the post, and things like that. It will compile them at runtime on Node, and it can also run them on the client side at runtime as well. So there's some limitations to that. So there were some of the problems that I faced. You can't kind of refactor some of that GraphQL code. I tried moving it into a function. It didn't quite like that. There's some limitations around that I found. So I decided to leave it alone. But other than that, it's been pretty pleasant overall, I would say. But yeah, the weird part is the GraphQL static side in Node and how it builds it. And it can be a bit slow sometimes, but yeah, I'm pretty happy with it. It optimizes images for you. And then you need to, the other limitation is anything that you want to do, you'll kind of need sending an email is a good example. So if you want to have a contact form, you can use, there's a service, I forget what it's called, that I use to do that. So you'll need a service for everything that you have in your system. But you can usually find them, and the hosting is free. So paying nothing for your web hosting is kind of nice after paying like $10 a month or whatever for the last couple of years.
Okay, cool. Thanks.
Good question. Anybody else? Lucas, do you want to talk about the blockchain? Do you want to tell me how wrong I am and blockchain is going to save the world?
No, actually, I think you were very correct when you said that the thing is about the use case. Like any new technology, I guess sometimes people want to hammer it everywhere. And I guess that most of the people, or some people, don't understand what it is actually made for. So if you ever are in a position where someone says, or you might be thinking of employing blockchain to solve a problem, I guess maybe you should really consider not using a blockchain to solve a problem, because most of the time there's going to be a better solution. Blockchain is very, very interesting to solve problems that only the blockchain can solve, like things that really need to be decentralized and transparent and public. I think that's the case for blockchain applications and smart contracts and the currencies. You know, all of that makes a lot of sense, and it might actually save some part of the world, because I think maybe the world can benefit from more transparency and decentralization, but I don't think it's going to save our world right now, or our businesses. I think it really should be carefully considered and studied before using.
It's a really good way of putting it. Thank you for that. Sweet. Anybody else?
Cool. I guess we can wrap this up as well. If you guys don't
James,
mind, whoever,
if we're wrapping this up, I have a question for you, and
sure.
also maybe for Michael or everyone, because on the breakout session we were talking about GraphQL, and also Michael mentioned it as well, and I'm a big fan of the technology because you know, I see it as as someone who has worked on both sides of the wire. I see that the fact that you can expose data models to the front end, and that the front end can really know what to expect when they ask for something. It's something that really appeals to me, and I think a lot of work cannot be done that way. But of course, there are performance issues, and I made a presentation in Brazil and someone for Globo.com was there. Globo is like the biggest network from Brazil, and they have a huge online presence as well. And they said they could not do it because of performance issues. And on the other side, if you look at the companies that are actually employing GraphQL and, you know, like Facebook itself or GitHub or Airbnb or like these huge companies that, you know, they have found a way, I believe, to scale it. So I would like to know more about your experience, if other people have experience with that and the caveats they've encountered.
James, what did you tell me when I told you we're doing GraphQL? I'll let you answer most of this yourself.
Be careful. Mike and I actually talked about this 2 days ago. So I was saying our group, as Lucas was mentioning, our team builds basically a data engine, right? Actually designed by Peter. So Peter, feel free to interrupt me if you're still around. And the interface for it is GraphQL. Basically, we wanted an interface that, you know, sort of like a common language that other client applications can query data for. Now, you know, we're about 3 years in now using GraphQL, like hardcore pretty much. The client applications are, one of them is a visualization tool and storyboard tool, so it needs data to plot charts. Another one, it's called a remediation tool, but essentially it gets data and it allows customers to follow up with questionnaires on the data, etc. So I think if I look at it, like for our use case, it fits, but there are, not to say there aren't pain points. One of them is it allows you to send multiple reads into one request. Now, arguably, there are ways to get around that with JSON. Arguably, it's just not that straightforward in our experience. And the other thing that I find useful is when it comes to data operations, it's more expressive than JSON, right? Than a REST endpoint, like filtering, like expressions, right? Now, if you have those use cases, definitely something to consider. Also, it solves, in my opinion, it allows the client application to get back only what it requests. Typically JSON, you have one resource and you just get all like its properties, right? And conversely, it also allows you to nest better. Like to get multiple layers or children of that data. Of course, the performance part, you know, it depends on your backend, on your data store, really. The database will be the bottleneck. Internally right now, actually, we are working as well on spinning up another database, like instance. And basically the public facing application just will manage the data, will manage where to fetch and store the data. Optimizations that you need to do, it depends also on your use cases. Like in our case, for example, client applications need to index explicitly because the data that customers upload is very arbitrary. Pain points, I would say, I would say you have to keep the GraphQL API up to date with client applications, but it's a bit similar to REST. And then it depends on the internals. Like we have an abstract syntax tree in between to abstract sort of like the generation of the SQL, because we want to be able to, I don't know, integrate maybe a different kind of data store later. So that's a little bit of a process there that you need to define the syntax, you need to define the parser. Now with JSON endpoints, typically there's a parser already. Yes, you need to make sense of it, but with GraphQL you have more in the sense you typically are writing your own parser or extending the parser, right? So that's one of them. Performance-wise, again, it depends. It really depends on the underlying data, what you're doing with it, how much data you're requesting. In our experience, payloads can, like the return payloads can go out of hand in terms of size sometimes. So you have to put measures in with limits. Pagination is still, you still need to consider that, just like with REST endpoints. Yeah, that's all I would say. I would say, think about it. Just because it's GraphQL, it doesn't mean it fits your use case. Basically, with everything else that Mike said in this presentation. So,
can you elaborate on the cases that you believe are not worth using GraphQL or that you had problems with?
I can answer that one.
Go for it, Mike.
Because I feel like we had it. So what's the difference between having a dedicated RESTful API for a single client type of device? And by single client, I mean just the web. You don't have a mobile, Android, and so on. What's the difference between a RESTful and a GraphQL in terms of you don't get a lot of benefits at that point?
I think if I may, let's say you have this case that you have like just like one platform and not a lot of devices. But if you, of course, you want to optimize your application, and in different times you're going to have different kinds of data, and that changes over time. And the features, they evolve, and sometimes you need like a new field on a request that you already have. So in that case, you have to set up a task for a developer to change an endpoint or add a new endpoint, and then has to be in accordance with the front end, who's going to be the one who's going to take it there. And there's a contract that has to be reviewed. And I find that sometimes it's just, when you have GraphQL, even the people that are not developers can access and see your data model. On the company that I had in Brazil, just as an example, I didn't have an interface. I had a system to optimize Facebook campaigns, and I just had a person who operated it, and I taught him to use the graphical IDE. So he would use the queries without even knowing how to code. And also, if you have like a big API, you can discover a lot of things in that. Of course, I'm not saying that everyone should rewrite everything that they have on GraphQL. I just, since I like the technology, I would say that today, if I were to start like an SPA architecture, I would prefer that. But I'm very curious of knowing the cases where GraphQL is a bad move. Like of course, that you have this, the downside of a different kind of technology, and that has its trade-offs, you know, and a lot of people doesn't even consider. My company today, we don't use GraphQL, and I'm not proposing it because things are working the way they are, okay? But I'm very curious to know if there were actually a more technical or performance bottlenecks.
Yeah, we thought all of these things that you said. Like that's what we thought in 2019 when we started this. GraphQL is the way of doing future, and they label it modern, and they promise you that they'll solve all the problems in the world, but it just doesn't. And RESTful is a good starting point in my opinion. If you do like GraphQL, I'll say this: try Strapi. It lets you create a bunch of objects in a CMS-like manner and exposes a bunch of GraphQL endpoints for you. So it'll teach you how to design GraphQL interfaces. So disadvantage is you have a new way of designing things. So you can follow RESTful principles, but you'll need to kind of reinvent them into GraphQL. It doesn't have a way to organize your mutations, for example. And when you say that you want a new field, you still need to, so you get the field from the database, but you'll still need to define it. So here I have these serializers, and you can think of them as a GraphQL serializer. It'll just serialize it to different GraphQL types based on the request that you get. So that works pretty similarly, but you also need to put that field in there. You'll need to tell the serializer, the GraphQL type, that, hey, you actually now have access to the name or the title or description in this such and such model. So it doesn't absolve you of that responsibility. You'll also have to update your client-side queries to include that. So you'll have to put it in 2 places, versus before you only had to put it in 1 place. You only had to change your serializers. There, you're absolutely right that you can theoretically get less data. You have to be kind of careful how you query it. Apollo encourages you to use fragments, and we got in trouble doing that. So with Apollo, and our data is highly relational. Right. So for example, we have a seller, the seller have orders have order line items have products have sellers that they belong to, right? And we keep passing this data down, but when I pass you a product object, you might want to know who the seller is. And it's really easy in GraphQL to just ask for the seller field inside of this deeply nested structure. And that's going to be really expensive. So one of our friends actually works with James. He described it, mentioned our performance issues, and he described it this way. He said, hey, GraphQL is an n+1 query generator. ORM is an n+1 query generator. So you put an n+1 query generator on top of an n+1 query generator. So you get n to the power of 2 plus n plus n plus 1 or whatever plus 2. So that's what you get at the end of the day. And that was our biggest problems, right? So you get the performance benefits with less payload, but at the expense of having these insane n+1 queries that are really easy to do because that's what you want to do. And we have these same problems in traditional Rails applications, and any MVC application in ORM will have these same exact problems. It's just convenient to do that. And it's really hard to be disciplined and not to do that. So you'll have to put limits, like James said, on like the depth of your tree. You can all accidentally recursively call the same fields. And if you use the same, like for example, everywhere that you want the product, you want all the same fields in the product. That's what fragments are. But if you include like a seller inside of your product fragment, and then you try to get all the products that a seller has, you're getting the seller n number of times, right? Which is n+1 query. So you get like interesting things like that with GraphQL. So it's pretty interesting. The other thing I would say that we thought type safety was important, but what I personally found is that type safety in a small application, like small, I'm talking about, like, I don't know, less than 1 million lines of code or something, or less than a couple of 100,000 lines of code, it doesn't buy you a lot. And if the team is not as big, it doesn't buy you a lot of things. So libraries are really useful with type safety. So the type safety that GraphQL gives you is not all that important, but it adds a lot of overhead to the development cycle. But yeah, I'd love to hear like some proponents of GraphQL. The benefits that Airbnb is talking about of moving faster are really interesting to me. So if anybody has accomplished that, I want to hear it. What's that, James?
I see, thank you. I did just one of the things that you said I've accomplished to address is that you said that when you have like a product and you have the seller, and then you want the seller for each product, you have ways of first fetching all of the products, and when you're resolving the query, you're going to get all of the sellers and just make one seller query, and then reorganize everything and just give it to the client. This is something that I personally did, but I do understand that
there's a batch loader thing that Shopify wrote for, but it's not perfect.
Yes,
but yeah, you're right.
I used to do it in Python. My GraphQL was, let me see if I have the name of it. I don't have the name right now, but it's
Hey, you guys, I just want to jump in really quick. I think this is a great conversation, it's a great discussion, but I just want to let everybody else here who's not participating, if they want to go, we can kind of wrap this up. Thanks everybody for joining. We can continue this discussion for anybody who wants to stay and listen in. But thanks so much, Michael. It's been great.
Thank you, guys. It was a pleasure.
I actually do want to add the question from Lucas before around when not to use GraphQL. And I've been pondering about that. So it's interesting because in our data engine itself, we have two services. One is the sort of public facing that has the GraphQL interface. But the internal one that is only accessible so far by this public service is REST. And when I think about the differences is that the one with the REST endpoint, the data that it returns is basically fixed. It's about data table locations. It's like where to store the data, etc. There's never a point in time, or very rarely, that we need just a subset of it. Typically, you would want like the whole resource, the whole information about the data table, for example, in our case. So also similar on that note, I think if the service is small enough, it's tiny, couple of endpoints, and the data is not that vast. There's not a lot of like relationships between data, etc. Chances are you don't need GraphQL. Chances are GraphQL is an overkill.
I agree.
So what I find GraphQL useful for, again, it's like multiple reads, for example, inside one request. That in our case, for example, we spawn literally the equivalent of futures. Damn it, I forgot the Scala name. No, it is future, sorry, it is future. And basically you can execute those queries in parallel and then return weight and return with the whole payload. That makes it easier. And the other one is what I said is like expressivity. You can achieve expressivity with JSON. Heck, parts of our GraphQL interface have some JSON embedded in it. But it's just harder with JSON. And some people, I think, Lucas, you mentioned yourself that it's just a bit more intuitive when it comes to retrieving that kind of data. And again, a REST endpoint, typically, sure, you can put in like query strings, but typically you just want to get the whole resource and set and be done with it. And it's fairly small typically.
Thanks.
I would say you know that saying in terms of when you try to optimize something, I would say that my advice is don't do it yet. Similar with optimizing systems. GraphQL is no different, in my opinion.
And you think GraphQL is might be a premature optimization?
It could be in some cases. So Mike, sorry, I would never dream about using it in a startup. Well, never is an absolute. I wouldn't go there, but I would think very hard before I go there, because it's just the nature of startups as well. You want to start fast, right? GraphQL adds an additional layer of like the parsing, the syntax, etc.
I see. Thank you.
But
guys, this is Vinod. Just wanted to chime in on when you'd want to use REST instead of GraphQL. So like at Rocketplace, we use GraphQL, and there's also a couple of REST endpoints. And we have flexibility so that we can have REST endpoints if needed. So the main disadvantage of GraphQL, I would say, is you would encounter that when you need to upload binary data back to the server.
Yeah. Good
so like if you need to upload binary data back to the server, then what you'd have to do is you'd have to deal with strings or JSONs, and you'd have to encode that from the client, and you'd have to decode it back on the server. And we upload images and stuff, and so we base 64 encode them and then decode them back in the server and then upload it to the database or whatever.
That's a great point, actually, because when I think about it, our upload and export endpoints on our public service are not GraphQL. Like,
but they don't have to be, right?
Yeah,
of course, you can do like Vinod, and you can just have your GraphQL for the queries that make sense, and then also have REST endpoints for my point is just that as you know, when you have like, I also agree with the argument about small-sized applications. I don't think that makes much sense. But you know, middle-sized applications, which is I believe that most of us work on, I see the advantages of not having to write things over and over again, and I see that there are some problems. I want to go deeper into these problems more, but you know, I think I would just disagree that as a startup, I did that. So, and it kind of, you know, that I believe that was the thing that made my startup viable, because I did not have to write an interface. And if I did, I would have died, you know, many times. I almost died many times and it ended up dying, but GraphQL helped.
Okay, awesome. Glad it worked. Another one that I think about now, like in the context of export, I'm not sure other libraries, but the library that we use called Sangria for Scala, it doesn't do streaming, and I don't think GraphQL actually supports streaming on exports in general. That's something to think about. So now here's the good news. We have an export endpoint, and because we have this concept of the abstract syntax tree, we can actually reuse some of that for the purpose, for the export, like filters, for example. So it depends how the application is designed as well. But yeah, streaming, I think it's a limitation.
I just want to say that the library that I used in Python was Graphene. Graphene. So
yeah, we use Graphene and GraphQL at Rocketplace.
Cool. Okay, great discussion, guys. Also, feel free to continue to chat on the Slack group. It's interesting that GraphQL almost showed up in every talk we did so far. And I was trying to get a speaker, Drasko, but March was canceled. I'll see if I can ping him again, because I think, or maybe a member of my own team to give this talk. So we'll see whether we can go in that direction. It's parts of conversation and controversy sometimes. Awesome. So thanks a lot, everyone. Thanks for showing up and be part of this. And yeah, hopefully we'll see you soon. We'll figure out the next event. Otherwise, that's a wrap.
Thank you, guys.
Thanks, guys.
Everybody.
I'll bring a beer next time.
Yeah.
Yeah.